In this lecture, I'll show another interesting example of the KVL, another interesting application of the KVL. So if this is a loop and this is called a single loop circuit because there's just one closed path or just one loop. So the first thing whenever I see a loop, I know that there is some KVL being applied. So I'll just write applying KVL, and by convention I always move clockwise. So I'll just start off from this point, and the first sign I encounter is minus, so minus 120. And then because this is a resistor and I'm moving clockwise, so this would be plus and this would be minus, so I would write plus V30, the voltage across the 30 ohm resistor. Then I see this dependent current source, dependent voltage source, as I've mentioned in the previous lecture, that a dependent voltage source's value depends on some other value in the circuit, and here we can see that the value is 2VA, which is dependent on this VA. So I just write plus 2VA because I see the positive sign first. Then I move here, and here I'm given that this is VA, so I'll just write minus VA, and this is equal to 0. And if I simplify this, I'll see that it becomes minus 120 plus V30 plus VA is equal to 0. The problem is that there are two unknowns and I have just one equation, so I need to transform this somehow. The easiest way is to define a current in the circuit. Because this is a single loop circuit, there would all just be one current moving across the entire circuit in the clockwise direction by convention. So I can write that V30 is basically the current times 30, which means 30I. And then I can say that VA would be, because this is the positive side, I'll have to write minus. And by the way, I'm given the value of this resistance 2, which is 15 ohms, and I can write VA as minus I into 15. The reason I choose the minus sign is because whenever you use the Ohm's law, you need to see the current entering the positive side. So this current is leaving the positive side, so the negative of this current would be going upwards. So that is why I use the minus sign. So you need to make sure that the current you're using in the Ohm's law is entering the positive side. So VA would be minus 15I. So if I plug both of these here in this equation, I can see that it would become minus 120 plus 30I minus 15I. This is equal to 0, and I can use this to find the current, which comes out to be, so after solving, the current comes out to be 8 amps. And because I know the current in the single loop circuit, I now know all the values in this. For example, as I need to find VA, I can just see that as the current is 8 amps here, so I can apply Ohm's law, but I would have to use the current entering the positive side, which is below. So I'll write minus 8 times 15, which comes out to be 120 volts. So this is what VA is. So this is the trick behind the single loop circuit, that just write the whole KVL equation and then just substitute the current in this, and you can find an equation with just one unknown and you can solve that.